Hi, welcome to clickmyproject.com. The requested paper is Scalable and Modular Architecture for High-Performance Packet Classification. Let's move on abstract. Packet classification is a prominent technique used in networking equipment for various purposes. Its applications are diverse, including network security, access control list, traffic accounting, etc. To perform packet classification, one or more header fields of an incoming packet is checked against a set of predefined rules, usually referred to as a rule set or classifier. We use a bit vector-based approach to represent the rule set. Each rule is represented as a collection of subrules. We propose an algorithm named StrideBV to generate the subrules and modulate the BV architecture to achieve better scalability than traditional BV methods, which is an extension of field split bit vector algorithm. We introduce a pipeline priority encoder. A pipeline priority encoder for n-bit vector consists of log b n number of stages, and since the work done per stage is trivial, the PPA is able to operate at very high frequencies. In this paper, we adopt explicit transfers done in a serial fashion. The main reason for this choice is to not affect the uniformity of the pipeline stages significantly. We present the overall architecture of the proposed solution with two approaches, serial and parallel. In both serial and parallel orientations, each module is implemented as a separate pipeline. Once the module local highest priority match is extracted, this information is fed into the main priority encoder, which determines the overall highest priority match. The packet is treated based on the action specified in this rule. We evaluate the performance of both serial and parallel versions. We use memory consumption, throughput, power consumption, and overall packet latency as performance metrics in this evaluation. The next is flow diagram of the project. First, how to select the file for proceeding packet classification process, and the next one is vector generation using StrideBV algorithm. The motivation was to improve memory efficiency of the packet classification engine by exploiting various rule set features. And the next one is packet classification. Performing packet classification is challenging since it involves inspection of multiple fields against a rule set possibly containing thousands of rules. And the next process is send packets with security. We are sending packets with security, that is, we are splitting the packets and send to the client, and client getting the packets and merge the packets and view the original file and send acknowledgement to the server. And the next process is pipeline priority encoder. We use pipeline priority encoder for n-bit vector consisting of log b n number of stages, and since the work done per stage is trivial, the PPA is able to operate at high vary frequencies. And the next process is integration of range search. The main reason for this choice is to not affect the uniformity of the pipeline stages significantly. And the next process, modular architecture. The strides that process header fields with prefix and exact match index are using StrideBV stages, and strides that perform range comparisons are using range search stages. And the final one is performance evaluation. We evaluate the performance of both serial and parallel versions of StrideBV. First one is memory requirement. Memory requirement of StrideBV for a given packet classification rule set is strictly proportional to the number of rules in the classifier. And the next one is power efficiency. Power efficiency has gained much interest in networking community due to this reason. For smaller classifier sizes, the power consumption of the proposed solution is worse compared with the power consumption for the larger classifier size. And the final one is packet latency. The latency of the priority encoder can also be adjusted by approximately choosing the degree. Next is execution of project. Before starting execution, we have to create 3 folders for packet classification and receiving the original file and splitting the file. First, we have to load the file for proceeding packet classification process. Here we can view the details of file like file name, file size, and type of the file, and time to loading and classifying time of file. And next one is bit vector generation. Here we are assigning 4 rules for generating the bits. For that we have to load the file, and rule 1 we can view the bytes and generate bits, and rule 2 we can view here. For rule 3 it will generate it like this, and for rule 3 it will display here. And the next process is packet classification. For that we have to load the same file destination folder will be displayed here. And first we have to classify the file. File classified successfully. The classified will be displayed here, and splitted packets will be displayed here. And you can view the details of classified packets. That is original size, number of packets. There are 5 packets should be splitted, and file size, and finished time will be displayed in message box, and start time, end time, elapsed time. And we can also rar the file by compressing packets. 5 packets will be added to archive. Here rar file, we can view the rar files. And next one is send the packets to the client. For that we have to run the client side. For that we have to select the received path for the client. I am selecting the received path as receive, the folder which I am created early. And here how to select the file, and you can send button to send to the client, connection to the client. And here we have to start the server, starting and running and waiting to receive files. Connection is starting and file is sending and receiving data, disconnecting the server, saving the files, file transfer. And again this process will be same for each splitted package, that is 5 packets. File sending, disconnecting, and file will be transferred. And we can view the received file here. File will be received as original file, and we can also play the file here. Original file is received, and then we can close the file client side. And the next process is priority encoding using pipeline priority encoder, and we can view the generated bits here for the previously selected, and we can encode to know the lowest priority, and here we can view the highest priority for each fields by using rules. And the next process is integration range search. Here we are viewing the header bits that which we generated, and lower bound and then upper bound. And the next remaining range search, here we are viewing the header lower bound and less than and greater than, and we are viewing the less than and lower bound or upper bound bits, and we are 100 bits. And next we have to original bits and generating the lower than and greater than bits, and finally we are getting the under bits. And the next process, modular architecture using latency tolerant applications. First we have to view the header fields, that is generated bits which we generated for the each packets, and local highest priority for the using each rules, and we can extract the main priority enquiry for overall highest priority. And these bits are generated for each packets, and we can view the packet latency here, that is stimulation time, response time, delay tolerance, and latency range. And we can view the classification latency, that is stimulation time for classification latency, response time, delay tolerance, and latency tolerance. And the next process, performance evaluation for memory requirement. Here we can view the classifier size, and here we can view the stride size. And the next is power efficiency. Here we can view the performance for trade-off, and here for power consumption. And next one is for latency in modular stride BV using stride BV algorithm. Here we can view the packets and types. Finally we are selecting the generated bits for packets and the file size and file type, and we can view the performance of packet latency here. Thank you.